Welcome to AP Chem with Torrie and Hailey. Today we'll be demonstrating instant fire with sulfuric acid, sucrose, and potassium chlorate.
The materials include 18 molar sulfuric acid, a volumetric pipette, sucrose, solid potassium chlorate, weigh boats, an electronic balance to 3 decimal places, a mortar and pestle, and a fume hood. Take extreme caution when using the 18 molar sulfuric acid. As shown, wear protective gloves, goggles, and perform the reaction under a fume hood. Sulfuric acid is highly toxic by ingestion and inhalation. Avoid all body tissue contact. Begin by measuring about 2 grams of solid potassium chlorate on an electronic balance to 3 decimal places. Use a mortar and pestle to grind up the solid potassium chlorate into a thin powder. Measure 2 grams of sucrose on an electronic balance to 3 decimal places. Mix the sucrose and solid potassium chlorate and place on the bottom of the fume hood. Add a small drop of 18 molar sulfuric acid to the mixture.
The equation for this reaction is 8 potassium chlorate plus sucrose plus sulfuric acid. That makes 8 potassium chloride, 12 carbon dioxide, and 11 liquid waters.
To review, the overall chemical reaction is written at the top. 18 molar sulfuric acid was added to solid potassium chlorate and sucrose, forming solid potassium chloride, water vapor, and carbon dioxide gas. Sulfuric acid has a strong affinity for water, making it an excellent dehydrator. When added to a compound, sulfuric acid will pull water molecules out of the compound. In this demonstration, sulfuric acid was added to sucrose. The dehydration reaction produces elemental carbon and water. This reaction is extremely exothermic. The elemental carbon is referred to as carbon foam because it expands. The water is vaporized by the heat the reaction releases. Sulfuric acid acts as the energy source for the resulting reactions. The potassium chlorate acts as an oxidizer, forming potassium chloride and oxygen gas. The oxidation reaction proceeds after heat is released from the sulfuric acid dehydration. The oxygen gas produced further fuels the combustion reaction, ignited by the released energy from both reactions. The flame is purple because of the presence of the potassium ion, which burns lilac.
Here are our calculations. First, let's start with our central equation. Sulfuric acid mixed with sucrose produces solid carbon and liquid water, which quickly evaporates. The change in enthalpy of formation is the enthalpy of products minus the enthalpy of the reactants. So the enthalpies of sulfuric acid and sucrose are subtracted from the enthalpies of solid carbon and liquid water. This makes a change in enthalpy of negative 13.36 kilojoules per mole, proving that this reaction is very exothermic.